Welcome to the training for Mechanical Science Fundamentals, Ventilation Systems. The average time to complete this training is estimated to be 20 minutes. After you have completed this portion of training, you will be directed to the next training lesson in the series for further instructions. These are the objectives for this course. Ventilation systems control the environment and the spaces they supply. They do this by controlling airflow through a series of fans, dampers, and ducting. The air is cooled, heated, humidified, or dehumidified to provide the proper environment for personnel and equipment. Ventilation systems are also used to prevent the spread of contamination to the environment or the clean areas of buildings. The area with the highest potential for contamination are maintained at the most negative pressure. This ensures that air leaks into that area and not out. Flow control is also used to ensure areas remain clean. All the air to potentially contaminated areas passes through filters prior to being released. This airflow is also monitored for radiation to ensure proper filtration. Air supply units are used to provide a particular area or space with air at a specified temperature and relative humidity. It has the ability to heat or cool air coming into the building. This unit has filters to remove any particulate matter, a preheat coil to keep the cooling coil from freezing during cold weather operations, a cooling coil, and a booster heat coil to control temperature and humidity. The air supply unit does not draw from the building air, so it has to heat or cool air from ambient or outside temperature. Air handling units can be used in place of air supply units. Air handling units are similar to air supply units except that they can return air from the area and mix it with outside air and have a built-in fan. Recirculating building air reduces the heating and cooling load by returning heated or cooled air to the unit from inside the building or area. The purpose of fans in ventilation systems is to move conditioned air through the system. There are two primary categories of fans used in ventilation systems: centrifugal flow fans and axial flow fans. Fans are typically electric motor driven. Centrifugal fans draw air from the side and exit through the discharge. The flow of air through a centrifugal fan is similar to the flow of fluid through a centrifugal pump. Unlike axial fans, the motors of centrifugal fans are outside of the airstream. This is a symbol for a centrifugal fan. There are three general types of axial fans: propeller, tube axial, and vane axial. Axial fans move the air parallel to the axis of the fan shaft. Axial fans provide high airflow at low pressure in ventilation systems. They are used mostly to exhaust air or to circulate air in an area. The axial flow fan uses a multi-blade propeller to move the air in a straight path through the fan. The name vane axial is derived from the vanes which are located immediately before or after the impeller. The vanes are designed to straighten out the spiraling flow of the air from the impeller blades to increase the efficiency. The tube axial fan is the same as a vane axial fan except that it has no vanes. Fans of this type operate at low pressures and are usually installed so that they do not discharge through ductwork. Cooling coils are used to provide cooling and to aid in dehumidification. Cooling coils have chill water flowing through the tubes and air is blown across the tubes by a fan. Heat is transferred from the hot air to the cool water inside the tubes. The cooling is controlled by varying the cooling water flow through the coil. As the air is cooled, its ability to hold moisture decreases. When the air temperature falls to the dew point, the moisture condenses on the cooling coil and drains away. When this air is reheated, the relative humidity has been lowered. Heating coils installed upstream of cooling coils are called preheat coils. Preheat coils heat the supply air to an area and prevent cooling coils from freezing during cold weather. Preheat coils are not operated at the same time as cooling coils. Booster coils are installed downstream of the cooling coils. These coils provide additional heat to the air when preheat coils cannot provide the required temperature. They also return air temperature to the desired value after dehumidification by the cooling coils. Humidifiers add moisture to the air entering an area. Humidifiers spray hot water or steam into the ventilation ducting to increase the humidity of the air. They operate with a temperature controller to maintain the temperature and humidity. These are typically used in winter during heater use that tends to dry out the air. Filters are installed throughout ventilation systems to remove particles from the airstream. There are several different types of filters used in ventilation systems. Filters are made of different materials with the capability of removing particles of different sizes. Some air handling units have two sets of filters: roll filters, which are low efficiency, and moderate efficiency or mod filters. Let's look at exhaust filters. One type of exhaust filter used at SRS is a high-efficiency sand filter. This high-efficiency filter is used to ensure any radioactive particles in the airstream are removed before entering the atmosphere. Typically, the final filter air passes through before being released to the environment is a high-efficiency particulate air or HEPA filter. HEPA filters are designed to handle any level of contamination. Air that is considered to be less contaminated is passed through a set of HEPA filters. These HEPA filters have an efficiency rating of 99.99% for particle sizes of 0.1 micron and larger. Dampers are like valves used to isolate or regulate airflow in ventilation systems. Dampers isolate components such as fans, sections of ducting, corridors, and cells. Dampers are physically located in the airstream and are shut to stop the flow of air. Dampers are also used to prevent the flow of air in an undesired direction, such as from a potentially contaminated area to a clean corridor. Types of dampers used in LWO include parallel blade, opposed blade, tornado, backdraft, and fire. A parallel blade damper has several blades parallel to one another. These dampers are used to isolate airflow. A rigid frame supports the galvanized steel or aluminum blades. The blades may have vinyl or silicone rubber sealing strips on the edges to provide a tight seal when the damper is shut. The blades are connected together by a linkage assembly which moves all the blades as a unit. A galvanized steel actuating rod connected to the blades moves them all together. The actuating rod is connected to a pneumatic or electric actuator. Opposed blade dampers are used to throttle flow. Each blade rotates opposite to the direction of the adjacent blade. Rotating the blades changes the area between the blades, controlling the flow through the damper. The mechanism used to operate opposed blade dampers is similar to that for the parallel blade dampers. The major difference is additional linkage is used to connect the opposing blades. Bubble-tight dampers are isolation dampers. Unlike the parallel blade damper, a bubble-tight damper is 100% airtight. This damper is used when absolute isolation is required by the ventilation system. They use parallel blades with silicone seals on the blade tips. When the blades close, the silicone tips on the blades provide a positive seal on the damper housing. A fire damper is a special purpose damper located in the duct as it passes through a fire barrier. A fire damper automatically closes during a fire. Fire dampers can be installed in either the horizontal or vertical position with coil springs. The spring provides a positive means of closing the damper by pulling the curtain shut. The damper is held open by an electric thermal device or a fusible link and are also equipped with a blade lock. The blade lock engages and holds the curtain blades shut after they have closed. Fire dampers do not reopen automatically. The fire department must open and reset the damper once it is closed. Tornado dampers are located as ducting enters a building. They isolate the duct and building if the outside air pressure goes below the building pressure, which can happen during a tornado. A tornado causes an extremely low atmosphere pressure, which can be less than the building pressure. Closing the tornado dampers prevents air and contamination from leaving the building. The damper reopens automatically when proper differential pressure is established. Tornado dampers have a set of blades that move to start and stop the flow of air similar to a butterfly check valve. They are normally open, but if outside air pressure drops below building pressure, the return spring closes the blades so that they seal against the damper housing, preventing the flow of air out of the building. Backdraft dampers are like ventilation system check valves within a building. They prevent reverse flow and control the spread of contamination through the ventilation ductwork. These special operation dampers are self-actuated and require no operator action. When reverse flow is sensed by a backdraft damper, the damper closes. When the proper differential pressure is established, the damper opens. The air-to-air supply units, or ASUs, is drawn in through filters. If drawing outside air, it will first pass through a roll filter and then a mod filter. After filtration, the air is heated and cooled as needed to maintain temperature and humidity. The system fans move the air through the system. Flow control dampers are used to maintain flow to various parts of the building or facility in proper proportion. Flow meters are used to monitor airflow and may position dampers automatically. Buildings that have, or have the potential to have, contamination in certain areas need controls to prevent the spread of contamination through the ventilation system. The purpose of a cascade pressure control system is to ensure that contamination control is maintained by keeping areas with the highest potential for contamination at the most negative pressure. This ensures that air leaks into an area or building and not out. By the use of flow control dampers and flow instrumentation, the ventilation flow can be manipulated to maintain areas at higher or lower pressure than others. By using opposed blade dampers to control flow and backdraft dampers to prevent reverse flow, area ventilation reduces the chance of contamination will spread. Small pressures on large areas can cause considerable force. Use caution around fan suction and discharge openings. Fan suction pressure will hold access doors and hatches closed or slam shut partially open doors, which could cause injury. Fan discharge pressure can blow access doors and hatches open with considerable force, which can cause injury. Another important consideration with ventilation systems is rotating equipment. Loose clothing and jewelry can get caught in the equipment. Hearing protection is required to be worn when personnel are around the larger fans while they were operating.